Welcome back to the deep dive. We're here to take your sources and really unpack the key insights, help you get informed fast. Today, we're diving into a really, mind-bending article. It's titled, "The Best Arguments for Photon Travel and Why They're Wrong."
Yeah, the source doesn't pull any punches. It goes right after the standard model of light, proposes this radical alternative called motion theory.
And the core idea, the foundation for all of it is boiled down to this one principle. Nothing travels, everything resolves.
Right. Just think about that for a moment. Instead of things moving, physically going from A to B, this theory says reality is about patterns, systems, structures reorganizing themselves, resolving.
Okay. So our mission today in this deep dive is to walk through how this single idea, this nothing travels principle, claims to offer alternative explanations for all those classic physics experiments, the ones we usually point to as solid proof that light particles, photons, actually travel.
Exactly. We're going to unpack how the source challenges that legacy view experiment by experiment.
All right, let's start with a big one, the photoelectric effect.
Okay, yeah. Good place to start.
So the standard view, Einstein's idea, got him a Nobel Prize, actually, is that light comes in these little packets, photons.
Right. Discrete packets of energy.
And when these photons hit metal, if they have enough energy, which means the light needs a high enough frequency.
Yeah, the frequency is key.
Then they can knock electrons right off the surface. And it's not about how bright the light is necessarily, but the energy per packet, the frequency.
Exactly. Intensity determines how many electrons get knocked off, but frequency determines if they get knocked off at all.
Okay, so that's the standard picture. What does this motion theory say? The source agrees the electrons do get ejected, right?
Oh, yeah, the experimental result isn't disputed. Electrons pop off instantly if the frequency is right. But the source says, nope, this isn't about energy packets arriving and hitting things.
Okay, so what is it then?
It's explained by something called sync collapse.
Sync collapse. Okay,
Yeah.
what does the source mean by that?
Well, it argues that electrons aren't just static points. They have an inherent internal rhythm, maybe like a motion loop structure.
A rhythm. An electron has a rhythm.
According to this theory, yes. An incoming light also has a rhythm, its frequency pattern. When that incoming light's rhythm hits a certain, maybe harmonic point with the electron's own internal loop, it destabilizes the electron structure. It causes that internal loop to sort of collapse, and that collapse ejects the electron.
So wait, no energy transfer from a particle? It's like
Right.
the light's rhythm just messes with the electron's rhythm until it breaks apart.
Precisely. It's an interference effect, a resonance, not a delivery of energy via a traveling particle. It's the electron's own structure failing due to this rhythmic sync.
Wow, okay. That's a really different way to frame it, a wild reframing. So how does this apply to the double-slit experiment? You know, the absolute classic of quantum weirdness.
The double slit. Right. The legacy view is already pretty strange, isn't it? You send photons, even one by one, towards two slits.
And they somehow create an interference pattern on the screen behind, like waves interfering with themselves.
Yeah. As if each photon went through both slits. But then, if you try to detect which slit it goes through.
Poof, the interference pattern vanishes. You just get two clumps, like particles.
Exactly. Usually explained as wave-particle duality, or the act of observation collapsing the wave function.
So motion theory's take, I'm guessing no particle involved?
You guessed it. Completely rejects the particle idea. No particle travels through the slits at all.
Then what causes the interference pattern?
The source says the pattern arises because the whole system, the source, the slits, the screen, is resolving what it calls ambient rhythmic tension. The light source introduces a rhythmic pattern into the setup.
Okay.
And the slits impose a structure on how that rhythm can resolve itself across the space to the screen. The interference pattern is that resolution.
Ambient rhythmic tension resolving. And what about when you try to detect which slit? Why does the pattern disappear then?
Because detection, in this view, isn't collapsing some mystical wave function of a particle that went through.
Right.
It's collapsing the interference structure itself. Putting a detector at a slit fundamentally changes the geometry of the system. It changes how that ambient rhythmic tension can resolve.
So you change the setup, you change the resolution pattern.
Exactly. Nothing actually traveled through in the way we think. The whole sync field of the experiment just restructured because you added the detector.
It's all about the system's overall pattern resolving, not a particle making choices.
Okay, let's move to Compton scattering. That one always felt like strong evidence for particles, like tiny billiard balls colliding.
Yeah, it's the standard picture, right?
Yeah.
An X-ray photon hits an electron, bounces off, loses some energy, changes direction, and the electron recoils. Looks just like a collision.
A very clear particle-on-particle interaction. Seems hard to argue with that visual. The source does argue, though. It says what you're seeing is rhythmic deformation and re-resolution.
Okay, more jargon. Break that down.
It means you don't need a photon particle.
Yeah.
The incoming X-ray has a rhythmic structure, a sync pattern. The electron has its own inherent motion loop when they interact. It's not a physical impact, it's the patterns interacting. This interaction distorts or deforms both patterns.
Yeah.
And then they immediately re-resolve into new stable patterns.
Yeah.
That re-resolution is what we see as the change direction and the recoiling electron.
So the collision is really a pattern interaction causing both patterns to shift and resettle.
Wow. The billiard ball analogy just falls apart then.
Completely misleading from this perspective.
Okay, let's zoom way out. The cosmic microwave background, the CMB, the Big Bang's afterglow.
Right, legacy view.
Yeah.
These are the oldest photons in the universe, released way back when the universe first cooled enough for atoms to form.
And they've been traveling across space for, what, 13.8 billion years? Getting stretched out by expansion, redshifted into microwaves? That's the story. Ancient light particles reaching our detectors today.
And motion theory says,
Nope, you're not detecting ancient travelers. The source claims what you're doing right now is syncing with the residual rhythm of the universe.
syncing with the universe's
Right.
rhythm.
Yeah. No photon particles started way back then and traveled here. The CMB, in this view, is the oldest coherent structure still within our sync range. It's a fundamental background rhythm, a pattern left over from the early universe.
Okay.
And our detectors are simply interacting with or resolving that pervasive pattern right here, right now.
That is profoundly different. Not catching old light, but tuning into an existing universal hum. Okay. If nothing travels, how on earth does the theory explain basic time-of-flight experiments? Shoot a laser, time the delay to a detector? Seems simple.
Seems simple. Seems like proof of travel, right? Measure distance, measure time delay, divide distance by time, get the speed of light.
Yeah.
Case closed, particles traveled.
Yeah, I mean, if I send something and it arrives later, didn't have to travel?
The source says a hard no. You are not measuring the travel time of a thing. What you're measuring is resolution lag across motion structures.
Resolution lag.
When the laser fires its pulse, it sets up a disturbance, a new pattern. The detector doesn't receive a particle that traveled. It takes time for the whole system, including the space between and the detector itself, to adjust, to resync, to resolve this new pattern that was introduced.
Ah, I see. So the time delay isn't the journey time.
It's the time it takes for the system to settle into the new state dictated by the laser pulse across that distance. The resolution process takes time.
Okay, that's tricky to wrap your head around. What about lunar laser ranging? Bouncing lasers off the moon? We measure the round trip, about 2.5 seconds. Seems like definitive proof of travel there and back.
Looks like it, absolutely. Standard view. 2.5 seconds is the time it took photons to make the round-trip journey to the moon's reflectors and back to Earth.
Motion theory's explanation must be interesting.
It is. It says you didn't send particles on a trip. You triggered a rhythmic echo within the larger Earth-Moon motion system.
A rhythmic echo.
Yeah. The laser pulse initiated a specific rhythmic disturbance in the sort of gravitational and spatial structure connecting Earth and the Moon. What comes back 2.5 seconds later isn't the particle returning.
Yeah.
It's the system completing a cycle. It's achieving loop closure in response to that initial rhythmic poke you gave it. The 2.5 seconds is the natural resonance or resolution time for that specific Earth-Moon system interaction.
Loop closure. An echo in the system. It really does sound more like music or biology than physics sometimes. Okay, redshift. Distant objects, like gamma ray bursts, look redder.
Standard explanation. Light travels vast cosmic distances. Photons lose energy battling that distance, or due to space expanding, stretching their wavelength towards red. Seems straightforward energy loss for a traveling particle.
Motion theory's version.
It calls it sync drift. The original rhythm, the pattern from the source, doesn't lose energy in the particle sense. Instead, its coherence, its precise timing, degrades as the pattern propagates or resolves across immense distances and through all the intervening stuff.
So the pattern gets fuzzy, less precise.
Kind of. It's sync phase diffusion. The rhythm smears out a bit, which we observe as a shift towards lower frequency, towards red. Not energy loss of a particle, but degradation of pattern coherence.
Sync drift, sync phase diffusion. Got it. What about Cherenkov radiation, that blue glow when particles go faster than light in water or some medium?
Yeah, the conventional view is the fast particle outruns its own electromagnetic field effects in the medium, creating a sort of shockwave that causes the medium to emit photons that blue light.
Photons being created and sent out.
Motion theory flips it. The particle exceeds the sync threshold of the medium. Its speed disrupts the normal rhythmic patterns of the water molecules, let's say.
Okay, disrupts the local rhythm.
Right. And this doesn't create photons. It causes a breakdown cascade, a chain reaction of these local patterns getting disrupted. What we see as light isn't emission. It's a rhythmic shock wave propagating through the medium because its normal sync structure was broken.
A shock wave in the rhythm of the medium itself.
Okay, practical application. Optical fibers. Sending light down glass cables for communication.
Standard view. Easy. Light pulses, photons, travel down the glass fiber, bouncing off the sides, maybe slowing down a bit in the glass, getting absorbed sometimes. Transmission.
Light particles literally traveling through the tube.
The source says, nope. You're watching rhythm pulses degrade and resync within a structured path. No travelers moving end to end.
So,
A rhythm pattern is started at one end. The fibers structure the glass, its shape acts like a channel, guiding the resolution of that pattern along its length. The signal stays coherent not because particles are flying through, but because the pattern is successfully resyncing, resolving itself along that guided path. It's signal coherence through guided motion. The fiber guides the resolution, not the particle. Okay, last one. The quantum eraser experiment. This one feels like pure quantum voodoo sometime.
it really does in the standard view. You set up a double-slit experiment, but you add a way to potentially get which slit information after the photon has supposedly passed the slits.
Right. And based on whether you do or don't get that information later, you can retroactively change whether you see an interference pattern or not. Seems like messing with the past.
Exactly. If you think a particle-decided wave or particle back at the slits, it makes no sense. Causes all sorts of philosophical headaches.
So motion theory's take, does it simplify this?
Dramatically,
Yeah.
according to the source. It says the outcome was never fixed back at the slits because nothing actually traveled through the slits in that way.
Okay.
You are simply adjusting how the system resolves sync tension when you implement the erasure part later on. The final pattern depends on the entire experimental setup, including the measurement choice made later. The system was always resolving based on all the conditions present.
So the end state depends on the total configuration whenever the final interaction happens. No retrocausality needed.
That seems to be the idea. The system resolves based on everything involved whenever it finally settles.
Wow. Okay, so stepping back, this source has basically gone through, 10 cornerstone experiments and observations: photoelectric, double-slit, Compton, CMB, time of flight, lunar ranging, redshift, Cherenkov, fibers, quantum eraser.
A whole slew of them.
And for every single one, it replaces the idea of a traveling photon particle with these concepts of rhythm, sync, patterns resolving, systems reorganizing.
That's the core thread, absolutely. The source insists the phenomena observed are real. We measured something.
But the interpretation...
The interpretation that it must be a particle traveling from A to B is, according to this source, fundamentally flawed.
So what does the source argue scientists actually saw in all these cases?
They saw sync collapse. They observed rhythm distortion. They witnessed structured loops realigning. They measured resolution lag.
Processes, dynamic interactions within systems.
Yes, but the source argues, because the idea of particles was already taking hold, they looked at these dynamic resolution events and...
named it a photon.
That's the source's claim. That the name itself locked in the concept of a traveling particle, creating decades of conceptual puzzles around things like wave-particle duality, when perhaps, in this view, it was never about a traveling thing at all.
So the motion theory perspective really boils down to, forget the particle, it was always a pattern, always a rhythm.
And crucially, you never received anything, you just resolved the motion. The interaction was local to you, resolving a pattern present in your vicinity.
The article wraps up with that very powerful line, "Welcome to the age of rhythm."
Yeah, it's quite a statement. It's asking us to fundamentally shift how we think about the universe.
And why?
Away from objects moving through space.
Towards thinking about space itself and everything in it as this dynamic medium of patterns, rhythms, structures, constantly resolving and resyncing. So this source gives us a truly revolutionary lens to view things we thought we understood pretty well, like light. It takes away the traveler, the photon, and gives us a universe governed by rhythm, sync, resolution.
It challenges that very basic intuition of motion, something going from here to there. It suggests what looks like transmission or travel is actually a ripple effect, a systemic reorganization resolving across a structure or space.
It leaves you with a pretty big thought experiment, doesn't it? If this principle, nothing travels, everything resolves, could potentially explain all these different light phenomena, what else might it apply to? What other fundamental ideas about physics, about reality, might need a similar radical rethink if we start looking for resolving patterns instead of traveling objects? What does it really mean to observe resolution instead of travel?